On a summer morning in 1977, nobody expected Voyager 1 to become the most distant explorer in human history. It was never supposed to. The mission was ambitious, but not immortal. Engineers built Voyager to visit giant planets. Scientists hoped it would survive long enough to study Jupiter and Saturn. A few years of operation would have been considered a success, perhaps a decade if everything went perfectly. Nobody imagined that nearly half a century later, the spacecraft would still be talking to Earth. And nobody imagined that it would eventually discover things no human being had ever seen before. The story begins with a misunderstanding. Most people think Voyager's greatest achievement was visiting the outer planets, the spectacular images of Jupiter's storms, the icy moons of Saturn, the rings, the colours, the discoveries. Those moments made headlines around the world. They felt historic, and they were. But in hindsight, those planetary encounters may have been only the opening chapter, because the real mission began after the cameras stopped taking pictures, after the planets disappeared behind it, after Voyager entered a darkness no spacecraft had ever crossed. For thousands of years, humanity believed the stars were unreachable. Ancient civilizations watched them move across the sky and imagined gods, spirits, and eternal fires. Later generations learned that stars were suns, that planets existed around them, that the universe stretched far beyond anything visible to the naked eye. Yet one problem remained. Between our sun and the nearest star lay an enormous unknown, a region no human artifact had ever entered, a frontier beyond the edge of the solar system itself. And for most of the 20th century, scientists weren't even sure where that frontier was. The boundary seemed simple. Surely the solar system ended where the planets ended. But then Pluto was discovered, then comets, then distant icy objects, then invisible magnetic structures. The farther researchers looked, the harder it became to answer a surprisingly basic question. Where does our solar system actually stop? Nobody knew. The answer depended on what you meant by solar system. Gravity extended far outward. The solar wind extended outward. Magnetic influence extended outward. Each definition created a different edge. Each edge created a different mystery. And Voyager was heading toward all of them. At launch, however, none of that seemed important. The spacecraft had more immediate concerns: survival, navigation, power, communication. Voyager carried computers that would appear primitive today. Its memory was measured in kilobytes. A modern smartphone contains millions of times more computing power, yet this small machine was about to travel farther than any technology humanity had ever built. The irony is difficult to ignore. One of the greatest explorers in history possessed less computing power than a digital watch. And yet, it succeeded. The spacecraft flew past Jupiter in 1979. What it discovered transformed planetary science. Volcanoes erupted on Io. Hidden oceans appeared possible elsewhere. Entire worlds looked different than expected. Scientists celebrated. The mission was already a triumph. Then, Voyager reached Saturn. Again, surprises appeared. Again, assumptions collapsed. Again, the universe proved more complicated than predicted. This pattern would repeat throughout the mission. Scientists expected one thing, reality revealed another. And nowhere would that pattern become more dramatic than beyond the planets, because once Saturn disappeared behind Voyager, something strange happened. The spacecraft kept going, year after year, decade after decade. It crossed distances so vast they almost defy imagination. The Earth orbits about 150 million kilometers from the Sun. Jupiter orbits roughly 780 million kilometers away. Pluto averages nearly 6 billion kilometers from the Sun. Voyager traveled beyond all of them, far beyond. And still, it kept moving. The planets gradually became memories. Sunlight weakened. The familiar architecture of the solar system faded into the darkness behind. Voyager was entering territory no spacecraft had ever explored. At first, scientists expected the outer solar system to become less interesting. The reasoning seemed logical. Closer to the Sun, planets existed. Moons existed. Complex environments existed. Farther out, there should be less to discover. Less matter. Less activity. Less mystery. The assumption sounds reasonable. It was completely wrong. The farther Voyager travelled, the stranger the data became. Particle detectors began reporting unusual changes. Magnetic measurements revealed unexpected patterns. The environment surrounding the spacecraft appeared different from predictions, subtle at first, then increasingly difficult to ignore. Imagine hiking toward a mountain hidden inside fog. At first, everything looks ordinary. Then the wind changes, the temperature changes, the ground changes. You cannot yet see the mountain, but you can feel its presence. Voyager was experiencing something similar. Something enormous existed ahead, something invisible, something scientists had never directly observed, and the spacecraft was moving toward it. Researchers soon realized they were approaching one of the greatest unexplored frontiers in the solar system. Not a planet, not a moon, not an asteroid, a boundary. A vast invisible border surrounding the sun itself. If Voyager could reach it, humanity might finally learn where our stellar neighborhood ended and where the wider galaxy began. The possibility was thrilling, but it carried another implication. If the boundary existed, then something existed beyond it. What was waiting there? Was interstellar space truly empty? Did the galaxy look the way scientists expected, or was something hidden in the darkness between the stars? Nobody could answer, because nobody had ever been there. Voyager was about to become the first, and hidden beyond that frontier was a discovery that would force scientists to rethink the solar system, the galaxy, and the nature of the space between stars. But before Voyager could cross the boundary, it first had to find it, and that turned out to be far more difficult than anyone expected. By the mid-1980s, Voyager had already accomplished everything it was built to do. Officially, the mission was a success, a spectacular success. It had transformed our understanding of the giant planets. It had revealed active volcanoes on distant moons, complex atmospheres, hidden oceans, new rings, new mysteries. Few spacecraft in history had achieved so much, and yet Voyager was still accelerating into the darkness. This was the strange thing about exploration. Sometimes the destination changes after the journey begins. The farther Voyager travelled, the less it resembled a planetary mission. The planets were becoming increasingly irrelevant. Jupiter was now hundreds of millions of kilometres behind, Saturn even farther. The spacecraft was moving toward a region no scientist had ever directly studied, a region that didn't appear on most popular maps of the solar system, a region that had no obvious landmarks, no worlds, no mountains, no visible horizons, only distance, endless distance. At first glance, it seemed like nothing, yet that nothing concealed one of the greatest mysteries in modern astronomy. Because scientists had begun suspecting that the outer solar system was not empty at all. Something enormous surrounded the sun, something invisible, something extending far beyond every planet, and Voyager was heading straight toward it. The realization emerged gradually. For centuries, astronomers viewed the sun primarily as a source of light and gravity. The star held the planets in orbit. It illuminated them. It warmed them. That seemed sufficient. Then researchers discovered another side of the sun. The sun was not merely shining, it was blowing. Every second, vast numbers of charged particles streamed outward from its surface. This flow became known as the solar wind. The name sounds gentle. The reality was anything but. The solar wind raced through the solar system at hundreds of kilometers per second. It carried magnetic fields, energy, momentum, the influence of the sun itself. Imagine a campfire in a dark field. The fire emits light, but it also emits heat. The warmth extends far beyond the flames. The solar wind was something like that warmth, an invisible extension of the sun reaching into space, and it reached much farther than anyone originally imagined. The discovery created a new question. If the solar wind continued expanding forever, it would eventually fill the entire galaxy. That clearly wasn't happening. Something had to stop it. Somewhere far beyond the planets, the solar wind must encounter resistance. Somewhere, a boundary had to exist. This idea fascinated scientists, because if such a boundary existed, it represented something extraordinary, a frontier. The outer edge of the sun's direct influence, the place where our stellar home confronted the wider galaxy. Yet, there was a problem. Nobody knew where that frontier was. Theoretical models offered estimates. Some predicted one distance, others predicted another. The numbers varied. The uncertainty remained enormous. Imagine trying to locate a coastline while standing in the middle of an ocean. You know land exists somewhere. You simply don't know where. That was essentially the situation. Researchers knew a boundary should exist, but they had never observed it directly. Then Voyager began approaching the region where the answers might be hiding. The spacecraft carried instruments capable of detecting charged particles, magnetic fields, plasma conditions. Exactly the kinds of measurements needed to investigate the outer frontier. Ironically, these instruments were never expected to become the stars of the mission. The cameras had captured public attention. The planets had captured public imagination. Yet now, the cameras were silent. The particle detectors were becoming the most important tools on board, and they were beginning to notice something strange. The environment around Voyager was changing, very slowly. almost imperceptibly, but undeniably. Particle populations behaved differently. Cosmic radiation increased. Magnetic conditions shifted. The farther Voyager travelled, the more unusual the data became. At first, scientists assumed the changes were routine. After all, the spacecraft was entering unexplored territory. Some surprises were expected. Then, the surprises kept coming, and coming, and coming. Patterns emerged that existing theories struggled to explain. The mystery deepened. Meanwhile, another realization was unfolding. The solar system itself might not look the way scientists imagined. Most illustrations showed a neat collection of planetary orbits surrounding the Sun. A tidy structure, orderly, predictable. Voyager was hinting at something far larger, a hidden bubble surrounding the entire solar system, an invisible cocoon extending billions of kilometers into space. This bubble would later become known as the heliosphere. At the time, however much about it remained uncertain. How large was it? What shape did it have? Where did it end? The answers mattered, because Voyager was heading directly toward that boundary, and whatever existed beyond it. Then came another intriguing clue. Scientists noticed that Voyager was encountering increasing numbers of cosmic rays. These particles originated far beyond the solar system. Some were born in exploding stars. Others emerged from violent events scattered across the galaxy. For most of the mission, the Sun's influence helped shield Voyager from many of them. Now that shielding seemed weaker. The galaxy was becoming more visible. The change was subtle, yet profoundly important. Imagine living inside a castle your entire life. The walls protect you from the outside world. As you approach the gate, unfamiliar sounds become audible. Distant voices, foreign languages, new smells. You begin sensing the larger world beyond. That was happening to Voyager. The spacecraft was approaching the gate, and the galaxy beyond was beginning to announce its presence. Yet the data created another puzzle. The increase in cosmic rays appeared stronger than some models predicted. Why? Was the boundary closer than expected? Was the solar system's protective shield weaker? Or had scientists misunderstood something fundamental? Nobody knew. The answers remained hidden somewhere ahead. And Voyager kept moving, year after year. Billion kilometre after billion kilometre, toward a frontier no spacecraft had ever reached, toward a boundary nobody had ever seen, toward a discovery that would eventually reveal that the space between stars was far stranger than anyone imagined. But first, Voyager would encounter something scientists had spent decades waiting to find: a hidden structure at the edge of the Sun's domain, a structure that should have behaved one way and behaved another. By the 1990s, Voyager had become something no one had planned for. It was no longer a planetary explorer. It was no longer a mission focused on worlds. It had become a scout moving ahead of humanity itself, a solitary machine advancing toward an invisible frontier, and somewhere ahead, scientists believed a collision was waiting. Not a collision between objects, a collision between environments, the Sun's domain and the galaxy beyond it. For decades, researchers had tried to imagine what this encounter would look like. The prevailing theory seemed straightforward. The solar wind raced outward from the Sun at supersonic speeds. Eventually, it would encounter enough pressure from interstellar space to slow down dramatically. Somewhere ahead, Voyager should encounter a gigantic shockwave, a boundary stretching around the solar system, an invisible structure larger than anything humans had ever explored. Scientists called it the termination shock. The name sounded dramatic. The expectations surrounding it were equally dramatic. According to theory, the encounter should be unmistakable. Voyager would detect abrupt changes. Particle behavior would shift. The solar wind would slow. The frontier would announce itself. At least, that was the prediction. But there was a problem. Predictions about the outer solar system had already failed before, again and again. Jupiter turned out stranger than expected. Saturn turned out stranger than expected. Its moons turned out stranger than expected. Why should the frontier be any different? Still, researchers waited, and Voyager kept moving. Meanwhile, a fascinating mystery was emerging back on Earth. The more scientists studied the heliosphere, the less certain they became about its shape. At first, most illustrations depicted it as a giant comet, a rounded front facing the direction of travel, a long tail stretching behind. The analogy made sense. The solar system was moving through the galaxy. Objects moving through fluids often develop tails. Simple. Logical. Perhaps wrong. New models produced conflicting answers. Some suggested compression, others suggested distortion. Others hinted that magnetic forces from interstellar space might be reshaping the entire structure. The situation became increasingly uncomfortable. Voyager was heading toward a boundary that nobody could accurately draw. Imagine sending an explorer toward a coastline while admitting you don't know where the coastline actually is. That was essentially what was happening. The farther Voyager travelled, the more valuable it became, because theory was reaching its limits. Only direct observation could settle the debate. Then, something unexpected happened. Voyager started finding clues earlier than anticipated. The spacecraft's particle detectors began recording unusual populations of energetic particles. These particles appeared different from the ones commonly observed deeper inside the solar system. Researchers immediately took notice. The frontier seemed to be announcing itself, like distant thunder before a storm. The spacecraft had not yet reached the boundary, yet it was already feeling its influence. The discovery generated excitement and confusion. Where were these particles coming from? How were they being accelerated? Why did they appear now? The answers remained unclear, but the mystery was deepening. Then came another surprise. The farther Voyager moved outward, the less stable the environment appeared. Scientists had imagined the outer solar system as a relatively simple place, sparse, quiet, predictable. Instead, the data suggested turbulence, complexity, structures hidden within structures. The frontier looked increasingly active, almost alive. Imagine approaching the mouth of a river where fresh water meets the sea. The boundary isn't a line. Currents collide. Waves overlap. The environment becomes chaotic. Researchers began wondering whether something similar was happening at the edge of the solar system. Perhaps the frontier was not a wall. Perhaps it was a zone. A vast interaction region where solar and interstellar forces collided. If true, identifying the exact boundary would become far more difficult, and that possibility carried enormous consequences. Because the entire mission depended on recognizing the crossing when it happened, how would scientists know when Voyager entered interstellar space? What measurement would count as proof? The question sounded simple. It wasn't. Some researchers argued that particle populations would provide the answer. Others favored magnetic field measurements. Others pointed toward plasma behavior. Different definitions produced different criteria. The debate intensified, and Voyager had not even reached the boundary yet. Then the spacecraft delivered another clue. Cosmic rays continued increasing. This observation was especially intriguing. Cosmic rays originate throughout the galaxy. Exploding stars, supernova remnants, extreme astrophysical environments. The heliosphere partially shields the solar system from them. As Voyager approached the frontier, that shielding appeared to weaken. The galaxy was becoming louder, not visually, but scientifically. Signals originating far beyond the sun were becoming easier to detect. The effect resembled approaching a city from the countryside. At first, the city is invisible. Then, distant lights appear. Then, distant sounds. Gradually, the presence of something larger becomes undeniable. Voyager was approaching the larger galaxy, and the galaxy was beginning to reveal itself. Yet one mystery overshadowed all the others. Where was the termination shock? Researchers expected it. Models predicted it. The physics seemed unavoidable, and yet Voyager continued travelling, year after year, billion kilometre after billion kilometre. Without encountering the dramatic transition scientists anticipated, the shock appeared late, or hidden, or different. Nobody could tell. The absence became a mystery in its own right. Imagine spending decades searching for a mountain. Every map says it should be ahead, every theory says it should be visible, and yet the horizon remains empty. Eventually, you stop asking where the mountain is. You start asking whether your map is wrong. That was precisely what scientists were beginning to wonder. Had they misunderstood the frontier itself? The possibility was unsettling, because if the termination shock wasn't behaving as expected, then the entire picture of the solar system's outer boundary might need revision. The mystery had reached a critical point. Voyager was now entering the region where theory and reality would finally confront one another. Researchers expected one of the most important discoveries in the history of space exploration. What they received instead was something even more valuable. A surprise, because when Voyager finally encountered the long-awaited shockwave, it did not behave like a boundary at all. For nearly 3 decades, the termination shock had existed as a prediction, an elegant piece of physics, a feature that seemed unavoidable. The solar wind raced away from the sun. Interstellar pressure pushed back. Eventually, the flow had to slow. Somewhere ahead, a shockwave had to form. The mathematics appeared sound. The logic appeared sound. Now Voyager was finally approaching the place where theory would meet reality. Scientists expected a dramatic moment, a clean transition, a textbook discovery. Instead, Voyager sent back something far more interesting: confusion. The first clues arrived gradually. Particle detectors aboard the spacecraft began recording strange bursts of energetic particles. The increases were significant, too significant to ignore. Researchers immediately recognized that something important was happening. The frontier was close. very close. Yet the data refused to tell a simple story. The particle populations behaved differently than expected. Some increased sharply, others fluctuated unpredictably. Certain measurements looked exactly like the signatures scientists had anticipated. Others contradicted them. It was as though the boundary was simultaneously revealing itself and hiding itself. Imagine hearing thunder from beyond a mountain range. The storm is clearly nearby, yet every time you climb a ridge expecting to see it, another ridge appears. That was the situation confronting researchers. The evidence suggested the termination shock was close, but the exact location remained elusive. Then Voyager detected a signal nobody expected. A flood of energetic particles appeared to be streaming outward from somewhere ahead. At first glance, the observation seemed impossible. The particles looked as though they were being accelerated near the frontier itself, and they were reaching Voyager before the spacecraft had actually crossed the boundary. The implication was startling. The shock was announcing its presence from a distance, like waves arriving on a shoreline before the storm that created them. Scientists suddenly realized they might be observing the frontier indirectly, not by crossing it, but by feeling its influence. The discovery generated enormous excitement, yet it also created new problems, because the observations didn't fit neatly into existing models. Researchers had expected the termination shock to behave like a relatively simple structure. Instead, it looked messy, dynamic, almost turbulent. The frontier seemed less like a line and more like a living system. The realization was deeply unsettling. Many theories assumed a fairly orderly boundary. Now Voyager was suggesting something much more complicated, and the surprises kept coming. The further the spacecraft traveled, the more unusual the particle environment became. Some days the measurements appeared consistent with a nearby shock. Other days the evidence looked contradictory. The frontier seemed to move, or change, or perhaps the spacecraft was passing through different regions of a much larger structure. Nobody knew. The mystery deepened. Then researchers considered a possibility few had fully appreciated. What if the termination shock wasn't stationary? The idea sounds obvious now. At the time, it carried profound implications. The sun is not constant. Solar activity rises and falls. The strength of the solar wind changes. Magnetic conditions evolve. If the solar wind changes, the boundaries created by the solar wind can move as well. The termination shock might expand, contract, shift position, like the shoreline of a lake responding to changing water levels. Suddenly, the missing boundary made more sense. Voyager wasn't approaching a fixed destination. It was approaching a moving target. The realization explained some observations, but not all of them. Several anomalies remained stubbornly unresolved. And then came another clue, one that would eventually transform the entire mission. Cosmic rays continued increasing. This trend had persisted for years. Researchers expected some increase near the frontier, yet the magnitude surprised many of them. The galaxy seemed to be leaking through the solar system's defenses more effectively than predicted. The observation raised uncomfortable questions. Was the heliosphere weaker than expected? Was the frontier more porous? Or had scientists misunderstood how cosmic rays interact with the outer solar system? Again, no clear answer emerged. The investigation was beginning to resemble a detective story. Each clue solved one mystery while creating two more, and Voyager was still moving deeper into unexplored territory. Then in late 2004, the situation changed dramatically. Voyager 1 encountered a region where the evidence suddenly became overwhelming. Particle populations shifted sharply. The characteristics researchers had long associated with the termination shock appeared unmistakably. After decades of anticipation, it seemed the spacecraft had finally reached the boundary. The scientific community celebrated. The prediction had been confirmed. The great mystery was solved. Or so it seemed, because almost immediately another problem emerged. The transition wasn't clean. The spacecraft appeared to move in and out of the region. Some measurements suggested multiple crossings. Others suggested a highly disturbed environment. The termination shock wasn't behaving like a wall. It was behaving like weather. The discovery stunned researchers. The boundary they had imagined for decades turned out to be far more complex than expected. There was no single dramatic crossing, no neat dividing line. Instead, Voyager appeared to be navigating a turbulent frontier filled with fluctuations and hidden structures. Nature had once again rejected simplicity. The implications were enormous. If the termination shock behaved this way, what about the final boundary itself? Would the crossing into interstellar space be equally messy? Would scientists even recognize it when it happened? The questions suddenly became urgent, because Voyager had crossed the first great frontier, but a much larger one still lay ahead. Beyond the termination shock stretched a vast region known as the heliosheath, a mysterious zone where the sun's influence weakened and the galaxy's influence grew stronger. No spacecraft had ever entered it. No human being knew what conditions existed there, and hidden within that region was the discovery that would eventually make Voyager famous. The first direct evidence of what truly exists between the stars. But before Voyager could reach interstellar space, it had to survive the strangest part of its journey, a region where almost every assumption about the edge of the solar system would begin to fall apart. After crossing the termination shock, Voyager entered a place no human machine had ever visited, the heliosheath. Even the name sounded mysterious. Most people had never heard of it. Few scientists had direct evidence about it, and yet this vast region occupied an enormous volume at the edge of the solar system. For decades it had existed mostly inside equations and computer simulations. Now, for the first time in history, a spacecraft was moving through it. What Voyager found was not what anyone expected. The heliosheath had often been imagined as a relatively straightforward transition zone, a region where the solar wind slowed down before eventually meeting interstellar space. Messy, perhaps, but understandable. Instead, Voyager discovered an environment filled with surprises. Almost immediately, the spacecraft detected energetic particles behaving in unusual ways. The patterns were complex, more complex than existing theories predicted. Some particles appeared trapped, others appeared accelerated. Still others seemed to originate from locations researchers struggled to identify. The deeper Voyager travelled into the heliosheath, the stranger the data became. Imagine entering a forest expecting a few scattered trees, and discovering an entire ecosystem hidden beneath the canopy. That was essentially what was happening. Scientists expected a boundary region. Voyager was revealing an environment. The distinction mattered because environments contain structure, and structure contains clues. Researchers began realizing that the heliosheath might hold the key to understanding the entire solar system's outer frontier. Then came another surprise. The solar wind itself was changing dramatically. For decades, Voyager had measured the outward flow of particles from the sun. The signal had always been there, reliable, predictable. Now it was weakening. Not disappearing, but weakening. The farther the spacecraft traveled, the more difficult it became to distinguish the familiar signature of the solar wind. It was as if Voyager were listening to a voice gradually fading into the distance. The sun still spoke, but the galaxy was beginning to speak louder. This transition fascinated scientists because for the first time they could observe the exact region where solar influence and galactic influence overlapped, not through theory, not through simulation, directly. And the overlap looked far more complicated than anyone imagined. The heliosheath appeared turbulent, dynamic, almost restless. Particle populations rose and fell. Magnetic conditions shifted. Structures emerged and disappeared. The frontier behaved less like a border and more like weather. That realization changed the mission. Before Voyager, many researchers imagined the edge of the solar system as a relatively clean separation. Inside, outside, simple. The data suggested otherwise. Nature preferred gradients, transitions, layers. The closer Voyager came to interstellar space, the less meaningful simple definitions became. Then another clue appeared: cosmic rays. For years, researchers had monitored them carefully. These particles originated far beyond the solar system. Many came from exploding stars, others from extreme environments scattered throughout the Milky Way. The heliosphere acts as a protective shield against them. Inside the sun's domain, cosmic ray levels are reduced. Outside, they become far more abundant. Scientists expected cosmic rays to increase as Voyager approached the frontier. What they did not expect was how dramatically they would increase. The spacecraft was detecting evidence that the sun's protective bubble was weakening. The galaxy was getting through. The discovery carried enormous implications because it suggested that Voyager was approaching something historic. The actual boundary between the heliosphere and interstellar space. The moment humanity had been waiting for since the spacecraft launched. The evidence looked increasingly persuasive. Yet, there was still a problem. One stubborn contradiction refused to disappear: the magnetic field. Researchers had long assumed that crossing into interstellar space would produce a major change in magnetic field orientation. The logic seemed straightforward. Inside the heliosphere, magnetic fields are largely shaped by the sun. Outside, they should be shaped by the galaxy. The transition ought to be obvious, yet Voyager wasn't seeing it. Not yet. This discrepancy became one of the most frustrating puzzles in the entire mission. Particle measurements pointed one way. Magnetic measurements pointed another. Which should scientists trust? The debate intensified, and Voyager, kept moving. Then, in 2009 and 2010, the mystery deepened further. Cosmic ray levels surged again. Solar particles declined again. The environment increasingly resembled what researchers expected beyond the heliosphere. The spacecraft appeared to be approaching a major transition. Some scientists believed the crossing was only months away. Others urged caution. Past experience had taught them a valuable lesson. The frontier rarely behaved as expected. Every apparent answer created new complications. Why should this moment be different? Then Voyager detected something truly extraordinary. Sudden changes, sharp changes, not gradual trends stretching over years, abrupt transitions occurring over much shorter timescales. The data looked almost like a warning, a sign that the spacecraft was approaching a boundary unlike anything previously encountered. Researchers watched closely. Every transmission mattered. Every new measurement was analysed in detail because everyone sensed the same thing. Something important was coming. Something historic. The spacecraft had travelled more than 17 billion kilometres from Earth. It had survived for over 3 decades. It had crossed the termination shock. It had traversed the heliosheath. Now it appeared to be approaching the final frontier, the actual edge of the sun's protective bubble. The moment seemed inevitable. The evidence was building. The excitement was building. The mystery was reaching its climax. And then in August 2012, Voyager's instruments recorded a set of measurements so unexpected that scientists would spend months arguing about what they meant. Because the spacecraft had finally found something beyond the edge of the solar system, the problem was that nobody could agree on what it was. It happened without warning. No dramatic alarm sounded aboard Voyager. No signal announced a historic crossing. No scientist sitting at a console suddenly shouted that the mystery had been solved. Instead, the most important moment of the mission arrived the same way most great discoveries arrive. As numbers, tiny changes buried inside streams of data. Easy to overlook. Difficult to interpret. Potentially revolutionary. On August 25, 2012, Voyager 1 recorded a sequence of measurements unlike anything it had seen before. At first, nobody fully understood their significance. The spacecraft continued operating normally. The transmissions continued arriving. Life on Earth continued, uninterrupted. Meanwhile, billions of kilometers away, humanity's most distant explorer may have crossed one of the greatest frontiers in the history of exploration. The first clue involved solar particles. For years, Voyager had measured particles originating from the Sun. These particles formed part of the familiar environment inside the heliosphere. They were signatures of home, evidence that the spacecraft still travelled within the Sun's domain. Then suddenly, they dropped. Not gradually, not over months. Abruptly, the decline was dramatic. Scientists studying the data immediately took notice. Something unusual had happened. Then came the second clue. At almost the same time, galactic cosmic rays surged. The increase was equally dramatic. Particles originating far beyond the solar system flooded the instruments. It was as if one environment had suddenly replaced another. The contrast was impossible to ignore. Researchers stared at the measurements. The implications seemed obvious. Voyager had crossed the heliopause, the boundary separating the heliosphere from interstellar space. After 35 years of travel, humanity had finally reached the space between the stars. The conclusion seemed irresistible, yet experience encouraged caution. Voyager had surprised scientists before, many times, and almost immediately a complication appeared. The magnetic field refused to cooperate. This single detail would trigger one of the most intense scientific debates of the entire mission. According to prevailing theories, crossing into interstellar space should produce a noticeable change in magnetic field orientation. The spacecraft should leave behind a field shaped primarily by the Sun and enter one shaped by the galaxy. The transition ought to be obvious. Instead, the magnetic field looks strangely familiar. Not identical, but far more similar than expected. The contradiction created immediate confusion. Particle data screamed that Voyager had crossed the boundary. Magnetic data seemed less certain. Which evidence should scientists trust? Imagine reaching what appears to be a new continent. The language changes. The wildlife changes. The climate changes. Everything suggests you have arrived somewhere new. Yet the landscape still looks familiar. Would you conclude that you crossed the ocean? Or would you wonder whether something about the journey remains incomplete? That was precisely the dilemma facing researchers. For months, debate consumed the scientific community. Some scientists argued that Voyager had clearly entered interstellar space. The particle evidence was overwhelming. Others remained skeptical. The magnetic field behaved incorrectly. Perhaps the spacecraft occupied some intermediate region, a previously unknown layer between the heliosphere and interstellar space. The possibility was fascinating and frustrating, because if true, the frontier was even more complicated than anyone imagined. The mystery had reached another level. Then researchers began examining the data in greater detail. Patterns emerged. Particle populations remained consistent with interstellar conditions. Cosmic ray levels remained elevated. Solar particles remained suppressed. The transition persisted. This wasn't a temporary fluctuation. Something fundamental had changed. The evidence continued accumulating, and yet the magnetic puzzle remained. Then came a breakthrough. Scientists started reconsidering one of their assumptions. What if the interstellar magnetic field happened to align with the heliosphere near the crossing point? The idea seemed simple. Its implications were profound. If the magnetic field outside the heliosphere ran in the similar direction to the field inside, then the dramatic rotation researchers expected might never occur. The contradiction suddenly weakened. The particle evidence and magnetic evidence no longer pointed toward different conclusions. They could both be correct. The frontier simply looked different than predicted. Nature had fooled everyone again. The crossing had happened, just not in the way scientists expected. This realization transformed the mission overnight. Voyager 1 became the first human-made object to enter interstellar space. The achievement was extraordinary, not because the spacecraft reached another star. It hadn't. Not because it left the sun's gravity. It hadn't. The achievement mattered because humanity had finally crossed a boundary no civilization had ever crossed before. For the first time, direct measurements were coming from beyond the heliosphere, the first direct measurements from the space between stars. The implications were enormous. Researchers suddenly possessed something they had never had before: ground truth. Actual data, evidence collected from within the interstellar medium itself. Theories could now be tested against reality. Assumptions could be challenged. Mysteries could be investigated. And almost immediately, Voyager began finding surprises. Because interstellar space did not look the way many scientists expected, the environment appeared denser, more structured, more dynamic. The supposedly empty darkness between stars contained hidden complexity. The crossing had solved one mystery and created several larger ones. This pattern was becoming familiar. Every frontier Voyager reached seemed to expand the unknown rather than reduce it. Yet one discovery stood above all the others, a discovery so strange that it would eventually allow scientists to do something nobody imagined possible. Listen to interstellar space itself. And when Voyager began recording the signals hidden within the darkness between stars, researchers realized the galaxy was not nearly as silent as they once believed. The discovery began with a contradiction. For generations, people have been told that space is silent. The statement appears in textbooks. Documentaries repeat it. Scientists explain it to students. Sound requires a medium. Air, water, solid material. Without a medium, ordinary sound cannot travel. Space, therefore, is silent. The logic is correct. The conclusion is incomplete, because by the time Voyager entered interstellar space, scientists were beginning to realize that the darkness between the stars was not empty enough to be truly silent. Something was there, something capable of carrying waves, and Voyager was about to hear it. The story actually began years before the crossing itself. Researchers had long known that interstellar space contains plasma, a thin mixture of charged particles drifting between stars. The density is incredibly low, far lower than any vacuum most people can imagine. Yet on cosmic scales, even tiny amounts of matter matter. The plasma surrounding Voyager formed an environment, an invisible ocean through which the spacecraft was moving. The problem was that nobody knew exactly what that ocean looked like. Theories existed. Models existed. Direct measurements did not. Then, Voyager crossed the heliopause, and suddenly the spacecraft found itself immersed in the medium scientists had spent decades trying to understand. The opportunity was extraordinary, yet it came with a complication. One of Voyager's dedicated plasma instruments was no longer functioning. At first glance, this seemed disastrous. The spacecraft had reached the very region scientists most wanted to study, and one of the key instruments was gone. It looked like terrible luck. Then, nature intervened. A few years earlier, the sun had unleashed a powerful eruption, one of many solar storms that periodically sweep through the solar system. Normally such events are interesting but routine. This one turned out to be historic. The disturbance travelled outward, past Earth, past the outer planets, past the heliosphere. Eventually it reached the region where Voyager was drifting. When the shockwave slammed into the interstellar plasma surrounding the spacecraft, something remarkable happened. The plasma began to oscillate, like a bell after being struck, like water after a stone falls into it. The surrounding medium started vibrating, and Voyager detected those vibrations. At first, the measurements appeared as strange patterns in the data, subtle fluctuations, rising frequencies, repeating signatures. Researchers quickly realized what they were seeing. Voyager was detecting plasma waves, not theoretical plasma waves, not simulated plasma waves, actual waves propagating through the interstellar medium. For the first time in history, the implications were enormous. Because plasma waves contain information, just as the pitch of a guitar string depends on its properties, the frequency of plasma oscillations depends on the density of the surrounding environment. By measuring the frequency, scientists could estimate the density. The interstellar medium itself was revealing its secrets. The discovery felt almost impossible. The spacecraft had effectively transformed interstellar space into an instrument. The galaxy was providing the signal. Voyager was recording it. Then someone made a decision that would capture public imagination around the world. Researchers converted the frequencies into audio. The result sounded eerie, haunting, a rising whistle emerging from the darkness between stars. The recording quickly spread through news reports and documentaries. Many people described it as the sound of interstellar space. Technically, that description wasn't entirely accurate. The frequencies had been translated into a form humans could hear. Yet emotionally it captured something real. For the first time, humanity could experience a representation of conditions beyond the heliosphere. The space between stars no longer felt abstract. It felt tangible, almost alive. But the real significance wasn't the sound itself, it was what the sound revealed. The frequencies indicated that the plasma surrounding Voyager was denser than many researchers expected. Not dramatically denser, but noticeably enough to challenge existing assumptions. Enough to force revisions. Again, Voyager was finding surprises. The supposedly empty region beyond the solar system appeared more substantial than anticipated. And this wasn't a one-time observation. More solar disturbances reached Voyager. More plasma oscillations followed. Again and again, the measurements pointed toward the same conclusion. The local interstellar medium possessed properties that many models had underestimated. The darkness between stars was becoming richer, more structured, more interesting. Then another realization emerged. The waves revealed something else. Interstellar space wasn't static. It changed, responded, evolved. Researchers often imagine the galaxy as a collection of stars floating in emptiness. Voyager suggested a different picture. The galaxy resembled an ecosystem, a connected environment where energy particles and magnetic fields continuously interacted. The stars were not isolated islands. They existed within a larger medium, and that medium had behavior. The analogy that many scientists found useful was the ocean. Ships crossing an ocean may focus on individual destinations, yet beneath them exists a vast, interconnected system of currents, waves, and pressures. The stars were the destinations. The interstellar medium was the ocean. Voyager was finally exploring the water itself, and what it discovered kept challenging assumptions. The density appeared higher, the structure appeared more complex, the medium appeared more active. Every answer created larger questions. Then came another intriguing clue. The plasma waves suggested that conditions surrounding Voyager were not uniform. Different measurements hinted at variations, subtle changes, possible structures. The local interstellar medium appeared to contain hidden complexity. Researchers had spent decades imagining interstellar space as a relatively smooth environment. Voyager was beginning to reveal texture, details, geography. The realization carried enormous implications, because if the local interstellar medium possessed structure, then the heliosphere itself might be responding to that structure. The shape of the solar system's protective bubble could depend on conditions beyond it, conditions that Voyager was only beginning to uncover. The frontier was becoming larger again. The story was no longer simply about crossing a boundary. It was about understanding the environment beyond the boundary. And the deeper scientists investigated, the more they realized that the supposedly empty darkness between stars was anything but empty. In fact, Voyager was about to discover evidence that the galaxy itself was pressing against the solar system, shaping it, compressing it, possibly even sculpting the boundaries of our stellar home. And hidden within that realization was one of the most important discoveries of the entire mission. The farther Voyager traveled into interstellar space, the more uncomfortable a particular question became. If the spacecraft had truly left the solar system's protective bubble, what exactly was surrounding it now? At first, the answer seemed obvious. Interstellar space, the region between stars, the larger galaxy. Simple. But Voyager had already taught scientists a dangerous lesson. Nothing about the frontier was simple. Every time researchers believed they understood the environment, the data revealed another layer hidden beneath it. And now the spacecraft was uncovering evidence of something invisible, something enormous. something powerful enough to shape the boundary of the solar system itself, a magnetic structure lurking in the darkness beyond the heliopause. The discovery emerged gradually. As scientists analysed measurements from Voyager, they noticed that magnetic conditions beyond the heliosphere behaved differently than expected. Not randomly, not chaotically, systematically. Patterns appeared. Directions remained surprisingly consistent. The data hinted at an organised magnetic environment surrounding the solar system. At first, this may not sound remarkable. After all, magnetic fields exist everywhere. Earth has one. The Sun has one. Galaxies have them. The universe is full of magnetism, yet the implications were profound. Because magnetic fields influence plasma, and plasma dominates interstellar space. Together they form invisible structures capable of shaping enormous regions. Imagine standing inside a forest during a thick fog. The fog itself appears shapeless. But if a powerful wind blows through the trees, invisible patterns emerge. The motion acquires structure. The environment becomes organised. That was what Voyager was beginning to reveal. The interstellar medium wasn't merely a cloud of particles. It was being guided, organised, shaped by magnetic forces, and those forces appeared stronger than many scientists anticipated. The realization triggered a major shift in thinking. For years, researchers assumed the heliosphere was shaped primarily by the solar wind. The sun pushed outward. Interstellar pressure pushed inward. The balance determined the boundary. Voyager suggested the story was incomplete. Magnetic fields from the surrounding galaxy appeared to play a much larger role. The solar system wasn't simply expanding into empty space. It was interacting with a magnetic environment. The distinction changed everything, because if magnetic fields influence the heliosphere, they could influence its shape, its size, its structure, the entire architecture of the Sun's protective bubble. Then another clue appeared. Voyager's measurements suggested that the magnetic field beyond the heliopause flowed around the heliosphere rather than crashing directly into it. The image fascinated scientists. Imagine a boulder sitting in the middle of a river. The water doesn't stop. It divides, flows around the obstacle, rejoins downstream. Researchers began suspecting that the local interstellar magnetic field behaved similarly. The heliosphere wasn't merely floating in the galaxy, it was redirecting the galactic environment around itself. And in turn, the galaxy was reshaping the heliosphere. The relationship was dynamic, mutual, continuous. The frontier looked less like a border and more like a negotiation. Then came a surprising realization. The strange magnetic field might explain one of the biggest mysteries from Voyager's crossing: the missing rotation. For years, scientists expected a dramatic change in magnetic field direction when Voyager entered interstellar space. That change never appeared. The discrepancy generated controversy. Some researchers even questioned whether the spacecraft had truly crossed the boundary. Now a new explanation emerged. If the interstellar magnetic field wrapped around the heliosphere in a particular way, the directions could remain surprisingly similar on both sides of the boundary. The contradiction dissolved. The puzzle pieces fit together. The crossing had happened. The environment simply behaved differently than predicted. Nature had once again chosen complexity over simplicity. But the magnetic mystery wasn't finished. Far from it. Because the stronger the local interstellar magnetic field appeared, the more important another question became. Where did that field come from? The answer led researchers deeper into galactic history. The evidence suggested that the magnetic environment surrounding the solar system was not a local phenomenon. It was part of something much larger. Ancient stellar explosions, shockwaves from long-dead stars, millions of years of galactic evolution. All had contributed to the conditions Voyager was measuring. The spacecraft wasn't merely detecting a magnetic field, it was detecting the aftermath of events that occurred long before humanity existed. The thought was astonishing. A machine launched in 1977 was measuring traces of processes millions of years old, processes written into the structure of interstellar space itself. The scale of the story expanded once again, from spacecraft to heliosphere to galaxy. And then another surprise emerged. Scientists began noticing that the magnetic field beyond the heliopause might help explain why cosmic rays behaved the way they did. Certain particles appeared guided, others appeared blocked. The field acted almost like invisible traffic control, directing motion, restricting motion, creating pathways through the interstellar medium. The implications were enormous, because cosmic rays influence the radiation environment of the solar system, and the heliosphere helps shield us from many of them. If magnetic fields shaped that shielding, then the galaxy itself played a role in determining the conditions surrounding Earth. The connection was subtle, yet profound. The solar system was not isolated. The Milky Way, was reaching inward, influencing our local environment, even here, even now. Voyager had become the first witness to that relationship. Then researchers noticed another pattern. The magnetic field appeared remarkably coherent over large distances. Interstellar space wasn't just structured, it was organized. The environment possessed hidden architecture, an invisible framework stretching through the darkness between stars, and that framework appeared to be influencing everything: the plasma, the particles, the heliosphere, possibly even the journey of Voyager itself. The discovery transformed how scientists viewed interstellar space. The old image of a random void was fading. A richer picture was emerging, a dynamic environment filled with forces, structures, and interactions. And hidden within that environment was another mystery, because while the magnetic field revealed how the galaxy shaped the solar system, Voyager was about to uncover evidence that the space beyond the heliosphere was denser than expected, much denser. And that discovery would force scientists to rethink what the darkness between the stars was actually made of. For most of the 20th century, interstellar space occupied a strange place in the human imagination. It was simultaneously enormous and empty. Astronomers understood that matter existed between the stars, but compared to planets, moons, and stars themselves, the amount seemed insignificant. The darkness appeared thin, almost absent, a vast vacuum interrupted only by scattered particles. Voyager was beginning to reveal a very different picture. The discovery emerged from one of the mission's most unexpected successes: the plasma waves, the strange oscillations that scientists had transformed into audible signals. At first, those waves were exciting, because they proved Voyager could measure conditions in interstellar space. Then researchers realized the waves were revealing something even more important: the density of the medium surrounding the spacecraft. And the numbers looked wrong. Not wildly wrong. Not enough to invalidate decades of research, but wrong enough to demand attention. Again and again, the measurements pointed toward the same conclusion. The local interstellar medium appeared denser than many scientists expected. The discrepancy was subtle, yet subtle differences become important when dealing with environments spanning trillions of kilometers. Imagine discovering that the air pressure surrounding an aircraft is slightly different than predicted. The difference may seem small, but over long distances the consequences can become significant. The same principle applied here. Density influences pressure. Pressure influences boundaries. Boundaries influence structure. A modest change could reshape the entire heliosphere. The mystery deepened. Researchers began re-examining older models. Some predictions fit the new data reasonably well. Others did not. Certain assumptions suddenly looked fragile. And whenever assumptions become fragile, science becomes interesting. Then another clue appeared. The density measurements weren't isolated events. Multiple plasma wave observations kept producing similar results. Different solar eruptions generated different signals. Different signals pointed toward the same conclusion. The consistency was difficult to ignore. Something about the local interstellar environment had been underestimated. But what? The possibilities multiplied. Perhaps the solar system occupied a denser region than expected. Perhaps the local interstellar cloud possessed hidden structure. Perhaps existing models oversimplified the medium entirely. Every explanation seemed plausible. None felt complete. The investigation expanded, as it often did. Then researchers considered a fascinating possibility. Maybe the heliosphere itself was influencing the density measurements. The idea sounds strange at first, but imagine a ship moving through water. Material accumulates in front of the bow. Pressure increases. Conditions further from those farther away. Could something similar occur at the edge of the heliosphere? Could the solar system's motion through the galaxy create regions of enhanced density? The hypothesis attracted attention, and for good reason. It offered a way to connect multiple observations: the shape of the heliosphere, the pressure of the interstellar medium, the structure of the boundary itself. Everything seemed linked. Yet the mystery refused to settle, because every answer created another question. This had become the defining pattern of Voyager's journey. Researchers solved one puzzle. A larger puzzle appeared behind it. Then came another realization. The density increase wasn't merely a local curiosity. It hinted at something much bigger. Interstellar space was behaving less like emptiness and more like an environment. The distinction sounds subtle. It isn't. A void is passive. An environment is active. A void simply exists. An environment interacts. Voyager was increasingly revealing interaction. Pressure, motion, structure, response. The medium surrounding the spacecraft behaved like a place with characteristics, a place with history, a place with hidden complexity. Then, scientists began asking a more ambitious question. If the local interstellar medium contains this much structure, What about the rest of the galaxy? The Milky Way suddenly looked different. For generations, stars dominated astronomical imagery, bright points scattered through darkness. Voyager was teaching a different lesson. The darkness mattered too. The regions between stars contained information, conditions, architecture. The galaxy wasn't merely stars separated by emptiness. It was stars embedded within a medium, and that medium played an active role in shaping everything around it. The realization was profound. It changed the scale of the story. Again, the mission had started with a spacecraft. Then it became a story about the edge of the solar system, then about interstellar space. Now it was becoming a story about the structure of the galaxy itself. And Voyager was driving every stage of that transformation. Then came one of the most intriguing implications of all. The heliosphere protects the solar system from many cosmic rays. Its effectiveness depends partly on external conditions. If interstellar density changes, the heliosphere changes. If the heliosphere changes, the cosmic ray environment changes. The chain of influence stretches all the way inward, toward Earth, toward life, toward us. The connection is indirect, yet real. A cloud drifting through the galaxy can influence the shape of the sun's protective bubble. That bubble influences cosmic ray shielding, and cosmic ray shielding influences the environment of the solar system. The galaxy reaches inward in ways few people ever imagine. Voyager was revealing those connections one observation at a time. Then another puzzle emerged. The plasma surrounding Voyager appeared not only denser than expected, but also surprisingly organized. Certain measurements hinted at hidden structures, gradients, regions, variations. The interstellar medium seemed to possess geography, not mountains and rivers. A different kind of geography. A geography of particles and fields. A geography invisible to human eyes. The discovery fascinated researchers because it suggested that the local galactic environment was far richer than previous generations realized. The frontier beyond the heliosphere wasn't featureless. It had texture, character, history, and perhaps most importantly, it had surprises. Many surprises. Voyager had crossed into interstellar space, expecting to answer questions. Instead, it kept finding new ones. Yet among all those mysteries, one discovery stood above the rest. A realization that transformed how scientists viewed the solar system itself. The heliosphere was not an isolated bubble drifting through emptiness. It was interacting continuously with the galaxy around it. The boundary wasn't a wall, it was a relationship. And understanding that relationship would reveal the most important thing Voyager ever discovered beyond the edge of our solar system. For decades, scientists searched for a boundary, a line, a frontier, a place where the solar system ended and interstellar space began. Voyager found that boundary, but in the process, it discovered something far more important. The boundary itself was not the story, the relationship was. This realization emerged slowly. At first, researchers focused on individual observations. The termination shock, the heliopause, the plasma waves, the cosmic rays. Each discovery seemed significant on its own, and each was significant. Yet as the evidence accumulated, a larger pattern became impossible to ignore. Every observation pointed toward the same conclusion. The solar system is not isolated. It never was. That sounds obvious today, yet for much of scientific history, people imagined stellar systems as largely self-contained. Stars generated planets. Planets orbited stars. Everything important happened inside the system. The galaxy existed around it. Distant. Detached. Voyager revealed something very different. The galaxy reaches inward. Constantly. Continuously. The interstellar medium presses against the heliosphere. Galactic magnetic fields shape its structure. Cosmic rays penetrate its defenses. Ancient stellar explosions leave fingerprints in the environment surrounding the sun. The solar system is not a sealed container. It is part of a larger ecosystem, and Voyager was the first spacecraft to show us that directly. The discovery may sound philosophical. It was profoundly physical. The evidence existed in the measurements themselves. Consider the heliosphere. Before Voyager, many illustrations portrayed it as a simple bubble surrounding the solar system. Useful. Neat. Easy to understand. Voyager complicated that picture. The bubble changed shape, responded to external pressure, interacted with galactic magnetic fields, adapted to conditions beyond itself. The heliosphere behaved less like a static object and more like a living interface. The implication was extraordinary. The galaxy was helping shape the architecture of our cosmic home. Then there were the cosmic rays. For years, Voyager observed their behavior changing as it approached the heliopause. The trend carried a simple message. The solar system's protective shield has limits. Beyond those limits, the galaxy becomes stronger. Its influence becomes more visible. The boundary wasn't merely separating two regions, it was regulating a relationship between them, like a coastline regulating interactions between land and sea. The analogy proved remarkably useful. A coastline is not simply where land ends. It is where waves arrive, where erosion occurs, where ecosystems interact, where forces meet. The heliopause appeared similar, a place where solar influence and galactic influence encountered one another, a place defined by interaction, not separation. Then came the plasma waves. Those strange signals detected after solar eruptions travelled beyond the heliosphere. The discovery carried a beautiful irony. Even in interstellar space, Voyager was observing consequences of events originating near the Sun. The connection persisted. The boundary did not erase it. Solar storms disturbed interstellar plasma. Interstellar plasma responded. Voyager recorded the response. The conversation continued across the frontier. The realization fascinated scientists because it challenged one of humanity's oldest habits. We tend to think in categories: inside, outside, here, there. Nature often prefers continuity, transitions, relationships. Voyager revealed those relationships everywhere it looked. Then researchers began asking a bigger question. If the solar system interacts so deeply with its galactic environment, what about other stars? The implications expanded immediately. The Milky Way contains hundreds of billions of stars. Many likely possess astrospheres analogous to our heliosphere. Each interacts with its surroundings. Each responds to local conditions. Each experiences pressure from the galaxy around it. Voyager had uncovered something potentially universal, a process occurring across the Milky Way, perhaps across the universe. The discovery elevated the mission beyond the solar system entirely. Voyager was no longer merely exploring our frontier, it was helping explain how stellar systems exist within galaxies. Then another realization emerged, one even more humbling. The local galactic environment surrounding the solar system is itself a product of older events. Ancient supernovae, long-dead stars, shockwaves that travelled across space for millions of years. The particles Voyager measured carried traces of that history. The magnetic fields carried traces of that history. The environment surrounding our solar system carried traces of that history. The present was connected to a distant past again. Relationships, connections, influences stretching across immense scales. The pattern appeared everywhere. The deeper scientists investigated, the harder it became to identify truly isolated phenomena. Everything seemed linked to something larger, the Sun to the heliosphere to the interstellar medium to galactic history to generations of stars. The hierarchy extended endlessly outward, and suddenly Voyager's journey looked different. The spacecraft hadn't merely crossed a boundary, it had revealed a hidden network, a web of interactions connecting our solar system to the Milky Way itself. That may be the most important discovery Voyager ever made. Not a single object, not a single measurement. A realization. The realization that our stellar home is deeply connected to the larger galaxy around it. Yet even this wasn't the end of the story, because every great discovery creates new questions. And Voyager's discoveries created one enormous question. If the region immediately surrounding the solar system contains so much hidden complexity, what else is waiting farther out? The spacecraft had travelled farther than any human artifact in history, and already it had encountered mysteries nobody predicted. The implication was difficult to ignore. The unknown surrounding us may be vastly larger than the known. Voyager had crossed the heliopause. It had entered interstellar space. It had revealed hidden structures in the darkness between stars. Yet perhaps its most important message was something simpler. The frontier is still there. The mystery is still there, and humanity has only just begun to explore it. If Voyager had crossed into interstellar space and immediately found exactly what scientists expected, the story would have ended much sooner. Instead, one of the strangest discoveries of the mission arrived in the form of an invisible storm. A storm made not of rain, not of wind, but of particles travelling at nearly the speed of light. For decades, astronomers had known that the galaxy is flooded with cosmic rays. The name sounds dramatic. The reality is even stranger. These particles are fragments of atoms accelerated by some of the most violent events in the universe. Exploding stars, supernova shockwaves, extreme stellar remnants, possibly even phenomena that remain only partially understood. Every second they race through the Milky Way in enormous numbers. And every second the heliosphere helps protect the solar system from many of them. Most people never think about this invisible shield, yet without it, the radiation environment around the planets would be very different. Voyager was about to show just how important that shield really is. The first clues appeared years before the actual crossing. As the spacecraft moved through the heliosheath, cosmic ray levels began rising steadily. At first, the trend seemed expected. The farther Voyager travelled from the Sun, the weaker the heliosphere's protection should become. More galactic particles should get through. Simple. Predictable. Then the increase became larger. And larger. And larger. Researchers started paying closer attention. The numbers weren't merely increasing, they were accelerating. The galaxy appeared to be breaking through the solar system's defenses more effectively than many models predicted. The observation generated immediate interest. Something important was happening at the frontier. The question was what? Then came August 2012, the same period that produced the mysterious particle transition and the debate over the heliopause. Suddenly, cosmic ray levels surged, not gradually, dramatically. The increase was so sharp that some researchers immediately suspected Voyager had crossed into a fundamentally different environment. The data looked extraordinary. Imagine spending your life inside a castle, protected by thick walls. A few distant sounds always make it through. Then, one day, the gates open. Suddenly, the outside world floods in. That was essentially what Voyager recorded. The spacecraft appeared to move from a region partially protected from galactic radiation into one exposed directly to it. The numbers were astonishing. Some categories of galactic cosmic rays reached their highest levels ever recorded during the mission. Meanwhile, particles associated with the Sun collapsed. The contrast could hardly have been more dramatic. Two environments seemed to exchange places almost overnight. Scientists studying the data realized they might be witnessing one of the clearest signatures of the crossing itself. The galaxy had arrived, or perhaps Voyager had arrived in the galaxy. The distinction was becoming increasingly difficult to make. Then another mystery emerged. Why did the increase happen so suddenly? Researchers expected a transition, yet many had imagined something more gradual, a slow blending between environments. Instead, portions of the data resembled a cliff. The change was abrupt, almost shocking. This suggested that the heliopause might be far more structured than expected. Rather than a smooth boundary, it could contain layers, barriers. Regions where particle transport changed dramatically over short distances. The frontier became more complicated again, as always. Then scientists began examining the cosmic rays themselves. Not all cosmic rays are identical. Different energies reveal different information. Different particles respond differently to magnetic fields. Different populations provide clues about the environments through which they travel. Voyager's measurements offered an unprecedented opportunity. For the first time, researchers could compare conditions on both sides of the heliopause directly. The results were fascinating. Some particles appeared strongly influenced by the heliosphere. Others barely seemed affected at all. The solar system's protective bubble functioned less like a solid wall and more like a filter. Selective, complex, energy dependent. The realization transformed how scientists viewed the frontier. The heliosphere wasn't simply keeping cosmic rays out, it was shaping their distribution, regulating their access, acting almost like a membrane between two environments. Again, the same theme emerged. Interaction rather than separation, relationship rather than isolation. Voyager kept uncovering variations of the same lesson. Then another implication appeared. Cosmic rays are not merely scientific curiosities. They influence real environments. They affect spacecraft electronics. They contribute to radiation exposure. Over long timescales, they may even influence planetary conditions. The heliosphere's shielding role suddenly looked more important than ever. Voyager was revealing how much protection the solar system receives simply by existing inside the Sun's magnetic bubble. Without that protection, the cosmic landscape would be far harsher. The discovery carried a subtle emotional weight. For most of human history, nobody knew this shield existed. Civilizations rose and fell beneath its protection without ever recognizing it. Voyager became the first messenger to travel beyond it and report what waited outside. The report was clear. The galaxy is a much more energetic place than it appears from within the heliosphere. Then came another fascinating observation. Cosmic ray levels beyond the heliopause remained remarkably stable. Researchers had expected fluctuations, variations. Instead, the interstellar environment often appeared surprisingly consistent. The implication was intriguing. The local interstellar medium surrounding the solar system possessed its own character, its own conditions, its own identity. Voyager was no longer measuring the edge of the solar system. It was measuring the nature of the galaxy itself. And every new dataset reinforced the same conclusion. The space between stars is not empty. It is active, dynamic, filled with particles carrying stories from across the Milky Way. Stories of ancient explosions, ancient stars, ancient events. Voyager was reading those stories directly. Yet among all these revelations, another mystery continued lurking beneath the surface. Because the cosmic rays revealed the presence of the galaxy. The plasma waves revealed the density of the interstellar medium. The magnetic fields revealed hidden structure. But scientists still didn't fully understand the shape of the heliosphere itself. And the answer to that question would prove even stranger than anyone imagined. For years, scientists believed they knew what the heliosphere looked like. The picture appeared in textbooks, scientific papers, museum exhibits, documentaries. It seemed intuitive. The sun moved through the galaxy. The solar wind pushed outward. Interstellar space pushed back. The result should resemble a comet. A rounded front, a long trailing tail. Simple, elegant. Understandable. There was only one problem. Voyager's discoveries kept producing clues that didn't fit that picture. At first, the inconsistencies seemed minor. Small discrepancies in particle behavior, unexpected cosmic ray distributions, magnetic field measurements that appeared slightly unusual. Nothing definitive, nothing dramatic. Then the evidence started accumulating, and a disturbing possibility emerged. What if the heliosphere didn't look like a comet at all? The idea sounded almost heretical. Entire generations of scientists had built models around the traditional picture. The comet-like heliosphere made intuitive sense. Yet nature has never shown much concern for human intuition. Again and again throughout the Voyager mission, reality had ignored expectations. Perhaps the shape of the heliosphere was no exception. The first hints came from cosmic rays. Researchers realized that the way particles entered and moved through the heliosphere depended strongly on its structure. Different shapes produced different particle distributions. Different particle distributions produced different measurements. Voyager's observations appeared increasingly difficult to reconcile with certain traditional models. The frontier was leaving clues. Scientists simply needed to interpret them correctly. Then, another piece of evidence arrived. The local interstellar magnetic field. Voyager had revealed that the magnetic environment beyond the heliopause was stronger and more organized than many researchers anticipated. That discovery carried important consequences. Magnetic fields exert pressure. Pressure influences structure. Structure determines shape. The heliosphere was not floating freely through empty space. It was embedded within a magnetic environment, an environment capable of sculpting it. Imagine blowing up a balloon inside a room. The balloon expands according to its internal pressure. Now imagine invisible hands pressing against it from different directions. The shape changes. The environment matters. Voyager was revealing that the galaxy itself acted like those invisible hands. The heliosphere wasn't merely created by the sun, it was co-created by the galaxy surrounding it. The realization transformed the debate. Researchers began developing new models. Some looked similar to the traditional comet picture, others looked radically different. Then one proposal captured widespread attention. Instead of a long comet-like tail, the heliosphere might possess two enormous magnetic lobes extending behind it. The comparison that quickly entered public discussion was unexpected. A croissant. The analogy sounded humorous. The science behind it was serious. Powerful solar magnetic fields could channel plasma into twin structures rather than a single trailing tail. If true, the heliosphere would look dramatically different than generations of scientists imagined. The reaction was mixed. Some researchers embraced the new interpretation. Others remained skeptical. The debate intensified, and Voyager sat quietly at the center of it all. Not because the spacecraft could directly photograph the heliosphere from outside. It couldn't. Instead, Voyager provided something arguably more valuable: constraints, real-world evidence. Every successful model had to explain the measurements, particle behavior, cosmic ray distributions, magnetic observations, plasma data. Theories lived or died based on whether they matched reality. The process resembled reconstructing an animal from footprints. No one had seen the creature directly, yet the tracks revealed its nature. Voyager was leaving tracks. Scientists were trying to identify the creature. Then, another realization emerged. The shape of the heliosphere might not be fixed. This possibility changed everything. Most people imagine boundaries as permanent. The edge of a continent, the shoreline of an island, the walls of a building. The heliosphere appears more dynamic. Solar activity changes. The solar wind changes. Interstellar conditions change. The shape responds, expands, contracts, adapts. The solar system's protective bubble behaves less like an object and more like a living process. The distinction was profound, because it suggested that the frontier Voyager crossed represented only one moment in a much larger story. Millions of years ago, the heliosphere may have looked different. Millions of years from now, it may look different again. The boundary possesses a history, a future, an evolution. Voyager had captured a snapshot, not a final answer. Then scientists began asking a larger question. If the heliosphere changes as the solar system moves through the galaxy, what determines those changes? The answer pointed outward once again, toward the local interstellar environment, toward interstellar clouds, toward galactic magnetic fields, toward ancient stellar events whose consequences still echo through space. The farther researchers traced the evidence, the more interconnected everything became. The sun influenced the heliosphere. The galaxy influenced the heliosphere. Ancient stars influenced the galaxy. Every scale connected to another. Voyager had become a guide through those connections, and each connection expanded the mystery. Then came one of the most fascinating implications of all. If our heliosphere possesses a unique shape, influenced by local galactic conditions, other stars likely possess their own versions. Astrospheres, invisible bubbles surrounding distant suns, each shaped by different environments, different magnetic fields, different histories. The Milky Way suddenly looked less like a collection of stars and more like an ocean filled with overlapping domains, each star creating its own sphere of influence, each interacting with the larger galaxy. The image was beautiful and humbling because it suggested that our solar system is neither isolated nor unique. It participates in the universal process, a conversation between stars and the galaxy around them. Voyager had uncovered the first direct evidence of that conversation. Yet perhaps the most surprising revelation still lay ahead, because once scientists began studying the local galactic environment itself, they discovered that the solar system was travelling through a region far stranger than anyone imagined. A region shaped by ancient stellar explosions, a region carrying the scars of events that occurred millions of years before Voyager ever launched. One of the most surprising things Voyager discovered beyond the edge of the solar system was that interstellar space has a memory. Not a memory in the human sense, not thoughts, not records, not stories. A different kind of memory. The memory of events, the memory of violence, the memory of stars that died long before humanity existed. At first, the space between stars seems timeless, dark, silent, unchanging. Yet Voyager's measurements told a different story. The environment surrounding the solar system wasn't random. It had been shaped, moulded, influenced by ancient events whose traces still lingered across the galaxy. The realization emerged slowly. Researchers studying the local interstellar medium began noticing something curious. The properties of the region surrounding the solar system appeared unusual, not impossible, not unique, but unusual enough to attract attention. The density, the magnetic structure, the motion of nearby interstellar material. Together, they suggested a history more complicated than previously imagined. Scientists started looking for an explanation, and that search led backward through time, far backward, millions of years, long before Voyager, long before Earth developed complex life, long before humans looked up at the stars and wondered what they were. The evidence pointed toward ancient stellar explosions, supernovae, the deaths of massive stars. These events rank among the most violent phenomena in the universe. A single supernova can briefly outshine an entire galaxy. Shockwaves race outward at incredible speeds. Matter is scattered across enormous distances. Entire regions of interstellar space are reshaped. And those effects do not disappear quickly. They persist, sometimes for millions of years. The possibility was astonishing. The particles surrounding Voyager might be part of a galactic landscape sculpted by long-dead stars. The spacecraft wasn't merely exploring distance, it was exploring history. Then researchers developed an even more intriguing idea. The solar system appears to occupy a region known as the local bubble. The name sounds harmless, almost insignificant. The reality is extraordinary. The local bubble is a vast cavity in the interstellar medium, a gigantic region of relatively low-density gas stretching hundreds of light-years across. Scientists believe it may have formed through multiple supernova explosions occurring over millions of years. Imagine detonating several enormous bombs inside a dense fog. The explosions clear out a cavity. The fog remains around the edges. The center becomes more sparse. The local bubble appears to have formed in a somewhat similar way. Ancient stellar deaths may have carved out a gigantic region surrounding our solar system. If true, Voyager was exploring a place shaped by catastrophes that occurred long before humanity existed. The implications were profound. The environment around the solar system wasn't simply part of the galaxy. It was a remnant of galactic history, a scar, An echo, a fossil left behind by ancient stellar violence. The discovery transformed how scientists viewed interstellar space. The darkness between stars stopped looking empty. It started looking archaeological, a landscape preserving traces of events from the distant past. Then another question emerged. If the local bubble resulted from supernova explosions, could evidence of those explosions still be detected? Researchers began searching, and the answer appeared to be yes. Measurements of certain radioactive isotopes found on Earth hinted that nearby supernovae may have occurred within the last few million years. Not close enough to destroy life, but close enough to leave measurable traces. The idea was both unsettling and fascinating. The solar system moves through a galaxy shaped by stellar death. Sometimes those deaths occur near enough to leave fingerprints behind. Voyager was helping place those fingerprints into context. The spacecraft had become a witness to a much larger story, a story stretching across millions of years and hundreds of light years. Then came another realization. The local bubble isn't isolated. Evidence suggests it connects to neighboring structures, other cavities, other clouds, other remnants of ancient events. The Milky Way began to resemble a patchwork landscape, a geography carved by generations of stars. Birth, life, death, explosion, renewal, again and again. The cycle repeats. Voyager had crossed the heliopause expecting to explore interstellar space. Instead, it found evidence of galactic history written into the environment itself. The scale of the mystery expanded once more. Then scientists noticed something even more remarkable. The magnetic fields measured by Voyager appeared consistent with this broader picture. Ancient shockwaves from supernovae can compress magnetic fields, reshape them, organize them. The structures Voyager detected may partly reflect processes set in motion millions of years ago. The implications were staggering. A spacecraft launched in 1977 was measuring consequences of events that happened before humans evolved into their current form. The connections stretched across unimaginable spans of time, and yet the evidence suggested it was real. This was becoming a recurring theme. Everything Voyager discovered beyond the solar system seemed connected to something larger. The heliosphere connected to the interstellar medium. The interstellar medium connected to galactic structure. Galactic structure connected to ancient stellar explosions. Every mystery opened into another. Every answer expanded the story. Then came a perspective shift that few people anticipated. For most of human history, the stars appeared permanent, fixed points of light, symbols of stability. Voyager was revealing another truth. The galaxy is constantly changing. Stars are born. Stars die. Shockwaves travel, magnetic fields evolve, interstellar clouds move. The environment surrounding the solar system today is not the environment that existed millions of years ago, nor is it the environment that will exist millions of years from now. The galaxy possesses weather, history, evolution. Voyager had become the first explorer to witness that reality directly from beyond the heliosphere. And the deeper scientists investigated, the clearer it became that the solar system's future might depend on where it travels next, because the Sun is moving through the Milky Way, and ahead of it may lie entirely different interstellar environments. Different clouds, different pressures, different conditions. Voyager had revealed that the galaxy is not uniform, which raised an unsettling question. What happens when the solar system enters a new region altogether? One of the most persistent illusions in human history is the feeling of stillness. The ground beneath our feet seems motionless. The sky appears stable. The stars look fixed in place. Yet almost everything in the universe is moving. Earth spins. Earth orbits the Sun. The Sun orbits the center of the Milky Way, and the solar system itself travels through interstellar space. Voyager helped reveal the consequences of that motion, because once scientists began understanding the environment beyond the heliosphere, they realized something remarkable. The solar system is not sitting inside a permanent cosmic neighborhood. It is traveling through the galaxy, and every journey eventually leads somewhere new. For decades, this fact remained mostly theoretical. Astronomers knew the Sun moved through the Milky Way. The evidence was clear. The calculations were straightforward. Yet the practical consequences were difficult to visualize. After all, interstellar space appeared largely empty. What difference could the journey make? Voyager changed that perception. The spacecraft revealed that the region surrounding the solar system possesses structure, density, magnetic fields, particle populations. The galaxy contains environments. Different environments create different conditions, and the Sun is moving through them. The realization was profound. Imagine a ship crossing an ocean. At any given moment, the water surrounding it seems normal, familiar. Yet over time, currents change, temperatures change, weather patterns change. The environment evolves. The solar system appears to experience something similar. Its galactic neighborhood is not permanent. It changes as the sun moves through the Milky Way. Voyager provided the first direct evidence that these environments matter. The heliosphere responds to external conditions. Pressure affects its size. Magnetic fields affect its structure. The local interstellar medium affects its behavior. Change the environment, and the heliosphere changes as well. The implications extended all the way inward, toward the planets, toward Earth, toward us. Then researchers began studying the local interstellar cloud in greater detail. This is the cloud through which the solar system currently travels. It is extraordinarily diffuse, yet compared to other regions of space, it possesses distinct characteristics, specific densities, specific temperatures, specific magnetic properties. The cloud helps define the conditions Voyager measures today. But there was another intriguing detail. The solar system may not remain inside this cloud forever. Evidence suggested that neighboring clouds exist nearby. Different clouds, different environments, different histories. The possibility fascinated astronomers because it implied that the heliosphere could change dramatically over long timescales. The frontier Voyager crossed today might not exist in exactly the same form millions of years from now. Then came a particularly intriguing question. What happens if the solar system enters a denser cloud? The answer remains uncertain, yet the possibilities are significant. Greater external pressure could compress the heliosphere. A smaller heliosphere would allow more galactic cosmic rays to reach the inner solar system. The radiation environment might change. The relationship between the Sun and the galaxy would change. Everything depends on conditions beyond the frontier. The idea sounded almost unbelievable. For generations, people imagined the solar system as an independent entity. Voyager revealed that its behavior partly depends on where it happens to be traveling through the galaxy. The realization felt almost ecological. A forest changes when climate changes. An ocean changes when currents change. A stellar system changes when its galactic environment changes. The parallels were difficult to ignore. Then, another mystery emerged. Scientists realized that reconstructing the solar system's past journey could reveal information about ancient conditions around Earth. Where had the Sun been millions of years ago? What interstellar environments had it crossed? What kinds of clouds had surrounded it? The questions opened entirely new fields of investigation. Voyager had unexpectedly connected astrophysics with planetary history. The spacecraft kept finding relationships where researchers expected separation. Then came another scale shift. The Milky Way contains hundreds of billions of stars. Most of them are moving. Most likely travel through changing environments. Most probably possess astrospheres analogous to our heliosphere. Suddenly, Voyager's discoveries looked universal again. The solar system wasn't unique. It was an example, a case study. One stellar system among countless others. The galaxy became less static and more alive. Stars drifted through interstellar clouds. Clouds evolved. Magnetic fields shifted. Boundaries adapted. Everything moved. Everything changed. Voyager had revealed a dynamic universe, not a collection of frozen objects, a collection of ongoing processes. Then scientists began asking perhaps the most ambitious question of all. Could interstellar environments influence habitability? The idea remains controversial. The details remain uncertain. Yet the possibility is fascinating. If the size and strength of a stellar system's protective bubble depend partly on local galactic conditions, then the broader galaxy may influence planetary environments in subtle ways. The connection would be indirect, complex, difficult to measure, yet potentially real. Again, Voyager was pointing toward relationships, toward hidden connections stretching across enormous scales. The spacecraft had become a messenger from the frontier, and the message kept repeating. Nothing exists in isolation. Not planets, not stars, not even stellar systems. The universe is woven together. Then another realization followed. The local interstellar cloud itself is only a tiny part of a much larger structure. Beyond it lie additional clouds, additional regions, additional mysteries. The solar system is traveling through a landscape far more complicated than previous generations imagined. A landscape Voyager had only begun to reveal. And somewhere within that landscape lurked a deeper truth. A truth that would transform the way scientists think about the space between stars. Because the more Voyager measured, the less interstellar space looked like emptiness. Instead, it looked like a hidden ecosystem connecting the entire galaxy together. At the beginning of Voyager's journey, most people thought about the galaxy in a very particular way. There were stars, and there was everything else. The stars mattered. The darkness between them did not. It was merely the backdrop, the empty stage upon which the real actors performed. Voyager slowly dismantled that idea, one discovery at a time, one measurement at a time, one mystery at a time. By the time the spacecraft entered interstellar space, a new picture was emerging. The darkness between stars was not empty. It was not passive. And it was certainly not irrelevant. In many ways, it was the thing connecting everything else together. The realization represented one of the most profound shifts in perspective produced by the mission. For centuries, astronomers naturally focused on visible objects: stars, planets, galaxies, nebulae. These were the things telescopes could see. The regions between them appeared blank. Yet Voyager was revealing that the blank regions possess structure, history, dynamics, influence. The darkness mattered. Then came a useful analogy. Imagine looking at a forest from high above. The trees dominate the landscape. They attract all attention, yet the trees survive because of the soil beneath them, the water moving between them, the nutrients connecting them. The invisible systems matter just as much as the visible ones. The galaxy appeared similar. Stars dominated human attention. The interstellar medium connected everything together. Voyager had become the first explorer to investigate that hidden infrastructure directly, and what it found was astonishing. Interstellar space contained plasma, magnetic fields, cosmic rays, shock waves, clouds, boundaries, regions of differing density. The environment looked increasingly complex, almost biological in its interconnectedness. Not alive, but organized, interactive, responsive. The distinction mattered, because once scientists began viewing the galaxy as a connected environment, many observations suddenly made more sense. The heliosphere interacted with the interstellar medium. The interstellar medium carried traces of ancient supernovae. Those supernovae influenced future generations of stars. Future stars created new planets. New planets developed new environments. The chain extended across cosmic scales. Cause and effect stretched for millions of years. Voyager had revealed part of that chain directly. Then another realization emerged. The galaxy itself might possess something resembling weather. The comparison is imperfect, yet surprisingly useful. Earth's atmosphere contains pressure systems, currents, storms, temperature gradients, conditions that evolve over time. The interstellar medium exhibits analogous behavior. Not rainstorms, not hurricanes, different phenomena entirely, but still dynamic, still evolving, still changing. Plasma flows through space. Shockwaves propagate through clouds. Magnetic fields shift and reconnect. Regions interact. Conditions evolve. Voyager had entered this environment and begun measuring it directly, for the first time in human history. The implications were enormous. Because weather influences everything living within an environment, likewise, galactic conditions influence the stellar systems embedded within the Milky Way. The connection may be subtle, but it appears real. Again and again, Voyager pointed toward the same conclusion. The solar system is part of a larger ecosystem. Then, researchers noticed another fascinating pattern. The local interstellar medium surrounding the solar system appears unusually informative. Not because it is unique, because it is accessible. Voyager happened to enter a region close enough to study a tiny sample of the much larger galaxy. Yet even this tiny sample revealed remarkable complexity. The implication was difficult to ignore. If one small corner of the Milky Way contains this many surprises, how many remain hidden elsewhere? The question lingered. It still lingers. Then another scale shift occurred. Scientists began comparing Voyager's discoveries with observations of distant stellar systems. Around many stars, astronomers detected evidence suggesting the presence of astrospheres, the stellar equivalents of our heliosphere. Invisible bubbles created by stellar winds, boundaries separating local environments from the wider galaxy. Voyager's measurements suddenly became valuable far beyond the solar system. For the first time, researchers possessed direct evidence about how such structures behave. Not simulations, not guesses, measurements. Reality. The mission had evolved again. Voyager was no longer merely explaining our frontier. It was helping explain stellar frontiers everywhere. The discovery elevated the spacecraft's importance enormously. Then came another realization. The interstellar medium may play a role in distributing matter throughout the galaxy. Elements forged inside stars do not remain there forever. Supernovae scatter them. Winds disperse them. Clouds transport them. Future stars inherit them. Future planets inherit them. Future life inherits them. The atoms inside human bodies were once part of ancient stars. Voyager was exploring the medium through which those atoms traveled. The thought was breathtaking. The spacecraft wasn't merely studying space, it was studying the pathways through which galactic history flows, the pathways connecting generations of stars, the pathways connecting the past to the future. Then another question emerged. If the interstellar medium is so important, why did it remain overlooked for so long? The answer was surprisingly simple. It is difficult to see. Human intuition favors objects, bright things, visible things. The interstellar medium often reveals itself indirectly, through effects, through interactions, through subtle signatures. Voyager changed that. For the first time, the medium itself became the subject of direct exploration. The invisible became visible. The forgotten became central. The background became the story. And perhaps that was Voyager's most unexpected achievement. It changed what humanity pays attention to. Then came an unsettling realization. Voyager had travelled farther than any spacecraft in history, yet in galactic terms it had barely begun its journey. The spacecraft remained astonishingly close to home. The nearest star was still unimaginably distant. The Milky Way still stretched across vast scales beyond comprehension, and yet even this tiny step beyond the heliosphere had transformed scientific understanding. The implication was profound. Humanity has explored only the thinnest outer layer of the unknown. The frontier beyond the solar system remains almost entirely untouched. Voyager opened the first door. The galaxy beyond still waits. And what that realization means for humanity may be the deepest mystery of all. By any reasonable standard, Voyager should have stopped working decades ago. That simple fact became one of the strangest parts of the story, long before it entered interstellar space. Long before it detected plasma waves, long before it transformed humanity's understanding of the frontier, the spacecraft should have fallen silent. Instead, it endured, year after year, decade after decade, as if refusing to accept that its mission was over. The irony is remarkable. Many of the most advanced technologies humanity has ever built become obsolete within a few years. Computers are replaced, phones are upgraded, satellites fail. Yet Voyager continued operating in an environment more hostile and remote than almost any machine had ever experienced. And because it survived, discoveries continued arriving, one after another. The spacecraft became more valuable with age, an outcome few people predicted in 1977. At launch, the mission planners had practical expectations. The spacecraft needed enough power to complete its encounters with Jupiter and Saturn. Anything beyond that was a bonus. Nobody was designing for half a century of operation. Nobody expected a machine built during the Cold War to become humanity's first interstellar explorer. Yet that is exactly what happened. The explanation lies partly in engineering. Voyager was built with extraordinary care, redundancies, backup systems, simple, reliable designs. The spacecraft carried radioisotope thermoelectric generators that converted heat from decaying plutonium into electricity. No solar panels could function at such distances. Sunlight becomes far too weak. Without nuclear power, the mission would have ended long ago. Yet even these generators possess limits. Every year the available power decreases. A little less electricity, a little less capability, a little less time. The decline is unavoidable. Voyager is slowly running out of energy, and scientists know it. This reality created a strange emotional dimension to the mission. Every new transmission feels precious. Every new measurement feels temporary. The spacecraft continues speaking, but everyone understands the conversation cannot last forever. Then came a series of unexpected challenges. As Voyager moved farther from Earth, communication became increasingly difficult. The distances involved are almost impossible to visualize. Radio signals travel at the speed of light. Nothing moves faster. Yet messages exchanged with Voyager still require many hours. A command sent today takes nearly a full day to arrive. A response requires another day. The spacecraft exists in a world of delayed conversations, a world where every interaction unfolds slowly. The situation resembles communicating with someone standing on the far side of a vast canyon, except the canyon spans billions of kilometers and continues growing wider. Then something remarkable happened. Even as systems aged, Voyager kept finding ways to continue operating. Engineers developed creative solutions. Unused components were reactivated. Software adjustments were made. Power budgets were revised. Every available watt became important. The effort resembled maintaining an ancient ship far from any harbour. Repairs occurred from a distance, often with limited options. Yet somehow the vessel continued sailing. The persistence fascinated the public, because Voyager had become more than a scientific instrument. It had become a character, a protagonist, a survivor. People followed its journey, not merely because of the data. They followed it because the spacecraft itself represented something deeply human. Curiosity, determination, exploration, the desire to keep going. Then another realization emerged. Voyager was entering a unique phase of existence. Most spacecraft operate within a known environment: Earth orbit, the Moon, Mars, the outer planets. Voyager occupied a category entirely its own. No previous spacecraft had travelled where it travelled. No companion missions surrounded it. No rescue was possible. The spacecraft was alone. Completely alone. The image is difficult to forget. A machine the size of a small car, drifting through interstellar darkness, far beyond the planets, far beyond the heliosphere, still transmitting, still working, still discovering. The symbolism is powerful because in many ways, Voyager's journey mirrors humanity's relationship with the unknown. We move outward, we gather information, we adapt when reality surprises us. And reality always surprises us. The spacecraft embodied that process. Then came another perspective shift. Scientists began thinking about Voyager not only as an explorer, but also as an artifact. One day, the instruments will stop functioning. The power will fade. The transmissions will end. Yet the spacecraft itself will remain. It will continue moving through the Milky Way for millions of years, long after the mission ends, long after the engineers who built it are gone, long after present-day civilization has changed beyond recognition. Voyager will continue its silent journey. The thought is haunting and strangely beautiful. Then researchers confronted another fascinating question. What will happen when communication finally stops? The answer is simple. Nothing. At least from Voyager's perspective. The spacecraft does not know whether Earth is listening. It does not know whether scientists celebrate its discoveries. It simply follows the laws of physics, orbiting the galaxy, carrying traces of its creators, moving endlessly through the darkness. The mission will end. The journey will not. This realization gave the spacecraft an almost mythological quality. Ancient explorers sailed beyond known horizons. Some never returned. Voyager represents a modern version of that story, an emissary travelling into regions humanity cannot yet follow, reporting back while it can, continuing onward when it no longer can, and all the while revealing mysteries nobody expected to find. Then another question emerged, perhaps the deepest question of the entire mission. What exactly has Voyager taught us? Not about particles, not about plasma, not about magnetic fields, about reality itself. Because after decades of exploration and discovery, a pattern had become impossible to ignore. Every frontier Voyager crossed appeared smaller than expected, and every mystery beyond it appeared larger. The spacecraft had reached interstellar space, yet instead of finding an ending, it found a beginning. And that realization was leading scientists toward one final conclusion. A conclusion not about Voyager, not about the solar system, but about the nature of knowledge itself. At first glance, Voyager's discovery seemed technical. Particle counts, magnetic fields, plasma densities, cosmic rays. The language belongs to science. The implications do not stay there, because beneath all the measurements lies a much larger story. A story about maps, not paper maps, mental maps. The invisible frameworks human beings use to understand reality. And by the time Voyager entered interstellar space, those maps had changed profoundly. For centuries, humanity's map of the cosmos was organized around visible objects. The sun, the planets, the stars. Everything else occupied the background. The empty spaces between things seemed less important than the things themselves. Voyager challenged that assumption again and again. The spacecraft kept finding evidence that the spaces between objects matter, sometimes enormously. The heliosphere exists in the space beyond the planets. The interstellar medium exists between the stars. Magnetic structures stretch across regions invisible to human eyes. The background turned out to be part of the story, a major part. The shift resembles something that happened in biology. Early naturalists often focused on individual animals. Then researchers began studying ecosystems. Relationships became just as important as organisms. Connections became just as important as objects. Voyager triggered a similar transition in astronomy. The solar system stopped looking isolated. The galaxy stopped looking empty. Connections became visible. Then came another transformation. Before Voyager, the edge of the solar system was largely theoretical. Scientists knew some kind of boundary should exist. The details remained uncertain. The frontier belonged more to models than observations. Voyager changed that forever. For the first time, humanity possessed direct evidence, actual measurements from the edge itself. The heliopause stopped being an idea. It became a place, A real environment, a real frontier. That distinction matters. There is a difference between imagining a coastline and standing on it. Voyager stood on it, and then crossed it. The achievement altered humanity's map of the cosmos, not metaphorically, literally. The outer boundary of the heliosphere could now be studied using direct observations. The unknown became partially known. Then, something even more interesting happened. The newly known territory turned out to be stranger than anticipated. This is one of the recurring themes in exploration. Reality rarely resembles the simplest prediction. The edge of the solar system was not a clean wall. The heliosphere was not shaped exactly as expected. Interstellar space was not empty. The galaxy was not passive. Every assumption required adjustment. The map changed again, and again, and again. Then researchers began recognizing another pattern. Voyager's discoveries consistently revealed complexity hidden beneath simplicity. The heliosphere looked simple from a distance. Up close it became complicated. The local interstellar medium looked empty from a distance. Up close it became structured. The boundary looked obvious from a distance. Up close it became ambiguous. The lesson extended beyond astronomy. Human intuition evolved for life on Earth, not for understanding cosmic frontiers. Voyager repeatedly exposed the limitations of that intuition, and in doing so, expanded it. Then another perspective shift occurred. Scientists realized that Voyager's journey represented more than exploration. It represented calibration, a way of testing assumptions against reality. Theoretical models predicted certain conditions. Voyager checked them. Sometimes the models succeeded. Sometimes they failed. Both outcomes were valuable because every discrepancy revealed something new. The spacecraft functioned like a bridge between imagination and observation, a bridge stretching billions of kilometers. Then came a fascinating realization. The farther Voyager traveled, the more its discoveries influenced fields far beyond the original mission. Astrophysics, plasma physics, cosmic ray research, stellar evolution, galactic structure, even studies of exoplanetary systems. The spacecraft had become relevant to questions nobody anticipated at launch. This often happens with major explorations. Their most important consequences emerge later, long after the original objectives have been achieved. Voyager exemplified that pattern perfectly. Then another mystery appeared, one that remains unresolved. Scientists now understand far more about the heliosphere than they did before Voyager, yet many questions persist. What is its exact shape? How does it evolve over long timescales? How does it respond to changing galactic environments? The spacecraft provided clues, not final answers. The frontier remains partly unexplored, and that may be the most important outcome of all. Because exploration is not valuable merely because it produces answers. Exploration is valuable because it reveals better questions. Voyager's questions are larger than the ones that existed before it launched. Larger, deeper, more ambitious. The spacecraft expanded the unknown. Paradoxically, that is one of the clearest signs of scientific success. Then came another realization. The map Voyager changed was not only scientific, it was psychological. Before the mission, interstellar space felt distant, abstract, almost mythical. After Voyager, it became tangible. A real environment, a place with measurable properties, a place humanity had actually entered. The psychological frontier shifted outward. The impossible became possible. The unreachable became reachable, at least in principle. That transformation may influence future generations more than any individual dataset, because maps shape behavior. People travel where maps suggest travel is possible. Voyager extended the map, then it extended it again and again. Now, for the first time in human history, interstellar space occupies a place on the map of direct experience. Humanity has been there through Voyager, and that simple fact changes everything. Yet perhaps the most extraordinary consequence of the mission still remains ahead, because once scientists began thinking seriously about the future, they realized Voyager had revealed something deeply unsettling. The solar system is not permanent. Its boundaries change. Its environment changes. Its relationship with the galaxy changes. Even our cosmic home is part of a larger process, and understanding that process may ultimately reveal more about our place in the universe than any boundary ever could. There is a quiet assumption hidden inside most people's view of the universe. The assumption is that the solar system is permanent. The planets orbit the sun. The sun shines. The boundaries remain where they are. Everything feels stable, unchanging, eternal. Voyager helped reveal how misleading that assumption can be, because one of the deepest discoveries beyond the edge of the solar system was not about what exists out there. It was about what exists here. Or more precisely, what does not exist forever. The heliosphere feels permanent because human lives are short. Civilizations are short. Recorded history is short. Against those timescales, the sun's protective bubble appears fixed. Yet the farther scientists followed Voyager's evidence, the more they realized that the heliosphere is temporary. Not temporary in the sense of days or years, temporary in the cosmic sense. A structure that changes, evolves, adapts, and eventually may look very different than it does today. The realization emerged from a simple observation. The heliosphere exists because the sun continuously emits the solar wind. As long as the solar wind pushes outward, the bubble survives. But the bubble is not expanding into emptiness. It is expanding into an environment. And environments change. Voyager revealed this with extraordinary clarity. The interstellar medium surrounding the solar system possesses density, pressure, magnetic structure, motion. The heliosphere must constantly respond to those conditions. The boundary is not fixed. It is negotiated, moment by moment, year by year, millennium by millennium. Imagine a shoreline. People often think of coastlines as permanent features, yet every wave alters them, every storm reshapes them, every century changes them. The heliosphere appears to operate similarly. The shape Voyager encountered is merely one version, one moment, one snapshot in a much longer story. Then, researchers began asking a provocative question. What did the heliosphere look like millions of years ago? The answer remains uncertain, but the possibilities are fascinating. The solar system has travelled enormous distances through the Milky Way during its history. Different regions contain different interstellar conditions, different clouds, different pressures, different magnetic fields. The heliosphere likely responded to those changes, expanded, contracted, changed shape, adapted. The frontier is not timeless. It has a history. Voyager was the first spacecraft to reveal evidence of that history. Then came another realization. The future may be just as dynamic. The solar system continues moving through the galaxy today. The journey never stops. Ahead lie regions not yet encountered, clouds not yet entered, conditions not yet experienced. The heliosphere will continue responding. Future boundaries may differ from present boundaries. Future shielding may differ from present shielding. The relationship between the sun and the galaxy will continue evolving. The implication is profound. Even our cosmic neighbourhood is part of a larger process. Nothing remains isolated. Nothing remains unchanged. Voyager kept uncovering variations of the same theme. Then scientists considered an even larger perspective. The sun itself is temporary. Like every star, it evolves, changes, ages. The solar wind will not remain constant forever. The heliosphere will not remain constant forever. Billions of years from now, the entire structure Voyager crossed may cease to exist. The thought is unsettling, yet it is also strangely beautiful. The heliosphere feels immense, and it is. Yet even immense structures participate in larger cycles. The universe operates through transformation. Stars transform, galaxies transform, boundaries transform. Nothing stands entirely apart from time. Voyager's discoveries reinforced that lesson repeatedly. Then, another scale shift occurred. Researchers began comparing the heliosphere to astrospheres around other stars. The similarities were striking. Many stellar systems likely possess protective bubbles of their own. Many likely interact with local galactic environments. Many likely experience changing conditions over time. The process appears universal. The solar system is not an exception. It is an example. One instance of a much larger phenomenon occurring throughout the Milky Way. The realization carried a subtle emotional impact. For centuries, humanity searched for uniqueness. Voyager revealed connection. The sun participates in processes affecting countless stars. The heliosphere participates in processes affecting countless stellar systems. The frontier beyond the solar system turned out to be part of a universal story. Then came another fascinating implication. If stellar environments change, planetary environments may change as well. Not dramatically, not necessarily quickly, yet subtly. Over immense timescales, the chain of influence stretches outward and inward simultaneously. Galaxy influences interstellar medium. Interstellar medium influences heliosphere. Heliosphere influences radiation conditions. Radiation conditions influence planetary environments. The connections are complex, yet real. Again and again, Voyager exposed hidden relationships. The spacecraft crossed a boundary expecting to find separation. Instead, it found connection. Then another realization emerged, perhaps the most unsettling one yet. Human beings often think of home as a place, a location, a stable environment. Voyager suggested a different interpretation. Home may be a process. The solar system itself is moving, changing, interacting, becoming. The cosmic neighborhood surrounding Earth is not frozen in time. It evolves. The frontier evolves. Everything evolves. The universe appears less like architecture and more like weather, less like a machine and more like a story. Voyager had become the narrator of that story, and the story was leading toward a final revelation. Not about plasma, not about cosmic rays, not about magnetic fields, about knowledge itself. Because after decades of exploration, one truth had become impossible to ignore. The farther Voyager travelled into the unknown, the larger the unknown appeared to become, and that may have been its most important discovery of all. When Voyager launched in 1977, scientists believed they were sending a spacecraft to study planets. That goal was achieved, then exceeded, then forgotten, because somewhere along the way, the mission became something much larger. It became an investigation into the limits of human knowledge, and the deeper the spacecraft travelled into the unknown, the clearer one pattern became. Knowledge does not eliminate mystery. Knowledge transforms mystery. At first, the challenge seemed simple. Find the edge of the solar system. Cross it. See what lies beyond. The plan sounded almost straightforward, yet every stage of the journey complicated the story. Scientists searched for the termination shock. They found it. But it behaved differently than expected. They searched for the heliopause. They found it. But it looked different than expected. They searched for empty interstellar space. They found it. But it wasn't empty. Again and again, the frontier refused to cooperate with expectations. The pattern became impossible to ignore. Every answer generated larger questions. The termination shock revealed the heliosheath. The heliosheath revealed the heliopause. The heliopause revealed interstellar space. Interstellar space revealed galactic structure. Galactic structure revealed ancient stellar history. The farther Voyager travelled, the larger the context became. The journey resembled climbing a mountain range. A traveller reaches the first summit, believing the destination has arrived. Then another range appears beyond it. Reach that range. Another appears. The horizon retreats endlessly. Voyager experienced something similar. The mission kept reaching summits. The universe kept revealing larger landscapes. Then came a realization that many scientists found surprisingly humbling. The spacecraft had travelled farther than any human artifact in history. Yet compared to the scale of the galaxy, it had barely moved. The nearest star remains over 4 light-years away. Voyager has travelled only a tiny fraction of that distance. The Milky Way spans roughly 100,000 light-years. The spacecraft remains extraordinarily close to home, and yet even this tiny step produced major discoveries. The implication is difficult to avoid. If one small excursion beyond the heliosphere revealed so many surprises, how much remains hidden elsewhere? The question lingers. It should linger. Because Voyager's discoveries suggest that ignorance is not a shrinking island surrounded by growing knowledge. The opposite may be closer to the truth. Every expansion of knowledge reveals larger regions of ignorance. The map grows. So does awareness of what remains unmapped. The mission illustrated this principle beautifully. Then another perspective shift occurred. For centuries, human beings viewed ignorance as a problem. Something to eliminate, something to overcome. Science often reveals a more subtle reality. Ignorance is also a resource, a source of questions, a source of discovery, a source of exploration. Without ignorance, there are no frontiers. Without frontiers, there are no voyages. Voyager existed because important questions remained unanswered. The spacecraft succeeded because it found better questions than the ones it started with. Then researchers began reflecting on what this meant for future exploration. The possibilities were staggering. Voyager had shown that direct exploration matters. Models matter. Theory matters. Observation matters too, but nothing replaces actually going somewhere, actually measuring, actually experiencing. The difference is profound. For decades, scientists built increasingly sophisticated models of the heliosphere. Voyager revealed where those models succeeded and where they failed. The lesson extends beyond the solar system. There are limits to what can be learned from a distance. Some mysteries require explorers. The spacecraft became a reminder of that truth. Then another realization emerged. The frontier beyond the heliosphere is still largely unexplored. Voyager sampled one path, one trajectory, one tiny region. The galaxy surrounding it remains almost completely unknown. Imagine dropping a single grain of sand into an ocean and using the result to infer the nature of the sea. That comparison is not entirely unfair. Voyager's journey was extraordinary. It was also only the beginning. The scale of what remains unexplored dwarfs everything discovered so far. Then came perhaps the most important philosophical lesson of the mission. Human beings often search for final answers, definitive conclusions, ultimate explanations. Voyager found very few. Instead, it revealed layers, connections, relationships. The universe appeared less like a puzzle with a final solution and more like a story without a final chapter. Every discovery connected to another mystery. Every explanation opened another door. The pattern repeated so consistently that it began to feel fundamental. Perhaps reality itself operates that way. Perhaps the goal is not to eliminate mystery. Perhaps the goal is to navigate it. Voyager seemed to suggest exactly that. Then another thought emerged, a haunting one. The spacecraft is still traveling, right now, as these words are being spoken. The mission continues. The journey continues. New data still arrives. The frontier remains active. The story is not over. One day, the signals will stop. The spacecraft will fall silent. Yet even then, the mystery will remain. Because Voyager did not solve the frontier, it revealed it. It illuminated the existence of questions larger than humanity previously imagined. And in doing so, it prepared the way for whatever comes next. The mission began as an exploration of the outer planets. It became an exploration of the edge of the solar system. It evolved into an exploration of interstellar space. Ultimately, it became an exploration of the unknown itself. And the unknown Voyager discovered is much larger than anyone expected. In the end, Voyager did not discover a monster waiting beyond the edge of the solar system. It did not find a hidden civilization. It did not uncover a secret structure spanning the galaxy. The truth was both quieter and more profound. Voyager discovered that the darkness itself was not what humanity thought it was. For centuries, the space between stars existed mostly as an absence, an empty gap separating meaningful places. The planets mattered. The stars mattered. Everything in between seemed secondary. Then a small spacecraft launched in 1977 crossed the heliopause and began sending back a different story. The darkness was not empty. The darkness had structure. The darkness had history. The darkness had a voice. And perhaps most importantly, the darkness was connected to everything else. That realization changed the meaning of the mission. At first, Voyager appeared to be traveling away from home, farther from Earth, farther from the sun, farther from everything familiar. Yet every major discovery revealed the opposite. The farther Voyager traveled, the more connections it found. Connections between the sun and the heliosphere, between the heliosphere and interstellar space, between interstellar space and ancient supernovae, between galactic history and the environment surrounding the solar system today. The spacecraft crossed boundaries only to discover relationships. Again and again, the pattern never stopped. Then came the most remarkable irony of all. Voyager was built to study planets. Its greatest discoveries occurred after the planets were gone. The cameras that captured Jupiter's storms and Saturn's rings eventually fell silent. The spectacular images ended, the public attention faded, and only then did the most important chapter begin. The mission became a detective story, a search for clues hidden in particles, magnetic fields, cosmic rays, plasma waves, tiny signals carrying enormous implications. The frontier beyond the solar system revealed itself piece by piece, not through dramatic events, through patient investigation, through evidence, through persistence. Then another realization emerged. The mission's greatest achievement may not be any single discovery, not the heliopause, not the plasma waves, not the cosmic ray explosion, not even the first direct measurements of interstellar space. The greatest achievement may be something simpler. Voyager transformed interstellar space from an idea into a place. Before Voyager, the region between stars belonged mostly to theory. After Voyager, it belonged to experience. Humanity had been there, through its machines, through its instruments, through its curiosity. The psychological frontier moved outward. The impossible became real. The unreachable became reachable. That transformation matters, because exploration changes what future generations believe is possible. Then came another perspective shift. Imagine looking at a map from centuries ago. Large regions are blank. The unknown occupies enormous areas. As exploration progresses, the blank spaces shrink. Yet something unexpected happens. The edges of the map become larger. The known world expands. The frontier expands with it. Voyager produced exactly that effect. The spacecraft reduced one mystery and revealed 10 more. The heliosphere became clearer. The local interstellar medium became more mysterious. Interstellar space became clearer. Galactic structure became more mysterious. Every answer widened the horizon. The mission became a demonstration of how discovery actually works. not as a path toward certainty, as a path toward deeper questions. Then there is Voyager itself, still traveling, still moving through interstellar darkness. The spacecraft has become something unusual, neither fully part of Earth nor fully part of the galaxy beyond. A messenger crossing a frontier that humanity cannot yet cross itself. Its signals grow weaker. Its power supply diminishes. One day, the transmissions will stop forever. That moment will come. Nothing lasts indefinitely. Not spacecraft, not civilizations, not even stars. Yet the end of communication will not be the end of the journey. Voyager will continue. For thousands of years, for millions of years, orbiting the Milky Way, passing through regions no human being has ever seen, carrying a record of its creators into the darkness. The image feels almost symbolic. A young technological civilization sending its first representative beyond the edge of its home, not because it knew what it would find, because it wanted to know. That distinction may be the most human part of the entire story. Curiosity launched Voyager. Curiosity sustained the mission. Curiosity transformed a planetary probe into an interstellar explorer, and curiosity continues to drive every question the spacecraft leaves behind. Then comes the final mystery. Not a scientific mystery, a philosophical one. Voyager revealed that the solar system is not isolated. The galaxy is not empty. The frontier is not a wall. Every apparent boundary connects to something larger. The farther we look, the more relationships we discover, the more interconnected reality appears. Perhaps that pattern extends beyond everything Voyager has found. Perhaps beyond the heliosphere lies another frontier. Beyond that frontier, another. And beyond that, another still. The spacecraft cannot answer those questions. Not yet. Maybe not ever. But it has shown us where to look. And sometimes that is enough, because the real message from beyond the edge of the solar system was never hidden in a single measurement. It was hidden in the journey itself, a journey that revealed how much exists beyond what we already know, a journey that transformed emptiness into discovery, a journey that reminded humanity of something easy to forget. The universe is still largely unexplored, the map is still unfinished, the frontier is still waiting. And somewhere ahead, beyond every boundary Voyager has crossed, beyond every mystery it has uncovered, beyond every answer it has helped reveal, the darkness continues, not empty, not silent, not understood. Waiting. Perhaps that is what Voyager truly discovered beyond the edge of our solar system. Not the end of the known world, but the beginning of a much larger one.